What would happen if the Earth started spinning twice as fast? Right now, you're moving faster than most commercial airplanes. And no, you don't need to be flying at an altitude of 10 kilometers or sitting in the cockpit to experience this. All you need to do is be on Earth. Our planet is constantly spinning on its axis. At the equator, the speed of this movement reaches approximately 1,670 kilometers per hour. We don't notice it only because everything around us is moving along with us: the air, the oceans, buildings, and even the atmosphere itself. But what would happen if one day the Earth started spinning twice as fast? At first glance, the consequences would seem fairly harmless. A day would shrink from 24 to 12 hours. In the time that currently constitutes a single day, people would see 2 sunrises and 2 sunsets. However, it would very quickly become clear that the change in the length of the day affects virtually all living things. The human body uses an internal biological clock that helps regulate sleep, appetite, body temperature, and energy levels. These mechanisms have evolved over millions of years to function within the familiar 24-hour cycle. If day and night began to alternate twice as fast, our bodies would have to adapt to a completely new rhythm of life. But the change in the time of day will be far from the most unusual effect. The Earth's equatorial circumference is about 40,000 kilometers. To complete a full rotation in 24 hours, the planet's surface moves at a speed of approximately 1,670 kilometers per hour. If the day were to be halved, the speed would automatically increase to 340 kilometers per hour. That's nearly 3 times the speed of sound. This raises an interesting question. If the Earth is spinning so fast, why don't we feel the motion? The reason is the same as why passengers don't feel the speed of an airplane during a smooth flight. As long as the motion remains uniform, the body perceives it as a state of rest. We don't notice the speed itself, but rather its change. However, an increase in rotational speed would change more than just our sensations. It would alter the very shape of the planet. Most people imagine the Earth as a perfect sphere, but in reality, it is slightly flattened at the poles and bulges at the equator. The planet's diameter across the equator is approximately 42 kilometers greater than across the poles. The reason is again related to rotation. The faster an object spins, the more it tends to expand at its center. That is why the equator is already farther from the center of the Earth than the North or South Pole. If the rotation speed doubled, this difference would become even more noticeable. But if the shape of the planet changes, could gravity change as well? It turns out, yes. The Earth's rotation already slightly reduces the force of gravity. This effect is particularly noticeable near the equator. As the rotation speed increases, centrifugal force will become stronger, so people will weigh slightly less. Of course, no one will start floating above the ground, but the sports world will certainly notice the difference. High jumpers and long jumpers would be able to stay in the air a little longer. Even a few extra centimeters could change world records and completely rewrite the history of professional sports. But if rotation affects people, what will happen to water? Oceans cover more than 70% of the Earth's surface, and their behavior is directly linked to the planet's rotation. The additional centrifugal force would gradually shift vast masses of water toward the equator. This means that sea levels near the equator will rise, while some regions closer to the poles may become land. Coastlines will begin to slowly change, new islands and bays will emerge, and familiar world maps will eventually cease to be accurate. However, the most dramatic changes will not occur in the oceans, but above them. Many people think of air as light and almost weightless. In reality, Earth's atmosphere weighs about 5 quadrillion tons. This is such an enormous mass that is hard to imagine. This entire gigantic envelope moves along with the rotating planet and constantly influences the weather. It is the Earth's rotation that creates the Coriolis effect, a force that causes air currents to curve. Because of this, hurricanes in the northern hemisphere typically rotate counterclockwise, while those in the southern hemisphere rotate clockwise. If the rotation speed increases, the Coriolis effect will become stronger. Winds will change their paths. Some regions will receive more precipitation, others will become significantly drier, and familiar climate zones will begin to gradually shift. Even airplanes will feel the changes. Modern aviation plans routes based on the movement of air masses. If wind patterns change, pilots will have to use entirely new flight paths. Some flights will become faster, while others will require more fuel. But the climate depends on more than just the air. All life on Earth exists thanks to a chemical process called photosynthesis. Plants use sunlight, water, and carbon dioxide to produce energy and oxygen. Every other breath a person takes is made possible by photosynthesis. If the day becomes half as long, plants will face a new challenge. They will have to gather the necessary energy in less time. Some species will be able to adapt, others will gradually disappear, and entirely new forms of life will emerge in their place. Such changes will also affect animals. Many birds orient themselves by the length of the day. Insects depend on nighttime, and some species structure their entire life cycle around the cycle of light and darkness. It turns out that a change in the Earth's rotation speed could disrupt entire ecosystems. But the consequences don't end there. Today, humanity relies on thousands of satellites. They power GPS, the internet, television, and communication systems. In order for a GPS device to pinpoint your location to within a few meters, computers constantly take into account the shape of the Earth and its rotation speed. If these parameters change, satellite systems would have to be reconfigured practically from scratch. This is where it becomes clear just how deeply the planet's rotation is embedded in modern civilization. But there is an even more surprising fact. The Earth doesn't just rotate on its axis. It simultaneously orbits the Sun at a speed of about 107,000 kilometers per hour. Every second, our planet travels nearly 30 kilometers through space. At the same time, the solar system itself is hurtling around the center of the Milky Way at a speed of about 800,000 kilometers per hour. It turns out that while you're sitting here, calmly watching this video, you're taking part in a journey of incredible scale. That's exactly why the question of the Earth spinning faster is so fascinating. It reminds us that our planet is not a stationary sphere beneath our feet, but a complex cosmic system where everything is interconnected. The length of the day affects the climate affects plants. Plants provide us with oxygen, and the planet's rotation helps power the technologies we use every day. And the most amazing thing is that all of this is happening right now. No special effects, no science fiction, no aliens involved. Simply because a massive planet with a diameter of nearly 13,000 kilometers has been orbiting in space with astonishing precision for billions of years, creating conditions for life that we have come to take for granted.